Okay, physics for today is just going to be a review of the homework over the last couple of days. I'm recording this, I don't even know what day it is. It's, good grief, it's Monday. It's Monday and it's like 7 o'clock at night. So I'm going off of the information I have about now. If you send me a message saying I had trouble with after that, hopefully I'm answering now whatever you were going to ask. A few people said, I just have problems with the whole thing. But a few people were a little bit more specific and said I had trouble with these numbers specifically. So if you had problems with the whole thing, I'm going to go over these ones, and hopefully whatever you're doing wrong throughout, we'll figure it out as through it, and then you can go back and retry some of those other ones. So if I'm not covering the question, I'm going to do 3, 4, 5, 9, and 11, because those ones seem to be the ones that were repeated as questions most often. As I looked through your homework and as I looked at messages that were left for me, those ones seem to be the ones that were repeated. 3, 4, 5, 9, and 11. Again, if your number's not on that list, I may answer the question that you have about it though when I do some of these, because most of them are done in a very similar fashion. So I'm going to start with number 3. Specifically, someone said the second part, but I'm guessing in order to get the second part, I'm probably going to have to do the first part, would be my guess. So, a cougar, no, that's not right. Number 3, a skier leaves the jump with a horizontal velocity of 22.4 meters per second. So my velocity in the x direction is 22.4 meters per second. And I've said it a whole lot on these videos, but I'm going to say it again. Remember that horizontal velocity does not change throughout the whole flight of the skier. If the landing point is 78.5 meters lower than the end of the ski jump, so that is a y displacement, right? Because the skier's starting up here and is going to end down here, 78.5 meters lower than when they started. The lower may come in, I haven't done the question yet, I don't know. We may have to make it negative, I'm not sure yet. We'll find out as we go. I haven't even read through the whole question yet. What horizontal distance did the skier jump? So I'm actually looking for the displacement for x is what I'm looking for. And then what was the skier's velocity when she landed? So I want final velocity. Again, please keep in mind that velocity means you must have an angle and a velocity. You have to, and a speed. You have to have both. All right. So for the first part, remember that time connects your calculations horizontally and vertically. I saw that actually written at the top of someone's homework. Good job keeping that at the forefront of your brain as you're doing the calculations. So I really can't figure out much horizontally at this point because there's no forces or anything doing anything, and I don't have a time. And really about the only formula I know when I have constant velocity is that velocity is equal to distance divided by time. And I don't have a distance and I don't have a time. All I have is a velocity. That's not going to help me very much. So I need to see if I can figure out time. So I do know that vertically, my vertical displacement is equal to my initial velocity times time plus 1/2 acceleration times time squared. So here's what I did. 78.5 is here. I did not bother to make it negative, and I'll explain why in a second. My initial velocity vertically is 0 because she launches herself horizontally, then she starts to fall. Think of the cartoons the Roadrunner and Wile E. Coyote, I know I'm probably like, just pretend, maybe you've seen them, where the coyote runs out over free space, hangs there, notices that he's hanging over free space, and then begins to fall, right? Goes a horizontal distance, then falls. Kind of think of it like that. So 78.5 is equal to 0 times time plus 1/2. Now my acceleration vertically is 9.81 times time squared. Now let me explain about the signs. I decided in this situation the down was going to be positive. The reason I did that was because her displacement is downward, acceleration is downward. They're both in the same direction. So it's just as easy to make them both positive rather than both negative. They're both in the same direction. I could have made this negative and made downward negative. It would work out the same. I just decided, why bother sticking a negative in if I don't need to? So I solved for that. That's gone. I did, this is 4.95 or 905. So I did 78.5 divided by 4.905, and then I did the square root of it, and I got that t was 4 seconds. And so I can get my horizontal displacement, because my horizontal displacement is equal to my, wrong formula. My horizontal velocity is equal to my displacement over my time, always in the x direction. Because I can use this formula because velocity in the horizontal direction is constant. So 22.4 is equal to my displacement divided by 4. So my displacement was really 22.4 times 4, which was 89.6 meters. So my displacement was 89.6 meters. Now, again, when she lands, so skier going down, when she lands, she's not straight down, she's at an angle. I know that her horizontal velocity is 22.4 because it remains constant. What I don't know is her final velocity in the y direction. I know the x direction, but I don't know the y direction. But I do know a formula that says final velocity is equal to initial velocity plus acceleration times time. I have that formula somewhere. So final velocity, that's for the y direction. Final velocity for the y direction would be 0 plus 9.81 times 4. So my final velocity in the y direction was 39.24. So now I have that this is 39.24. So if I want to know this, I just do the Pythagorean theorem with 22.4, so 22.4 squared plus 39.24 squared equals my final velocity squared. So I take the square root of both sides, and I get that my final velocity is, looking for it on my page, 45.2 meters per second. Now I said don't forget you need an angle. Tan theta equals y over x, so that is 39.24 over 22.4, so shift sign turns out to be 60 degrees, or 60.3 if you want. All right, so my final velocity is 45.2 meters per second at an angle of 60 degrees to the ground. It would be that angle right there. Okay, that's number 3. Number 4. Number 4 says something, there it is. An archer shoots an arrow towards a target, giving it a horizontal velocity of 70.1 meters per second. Horizontal velocity, 70.1 meters per second. If the target is 12.5 meters away from the archer, that's not a vertical distance, that's a horizontal distance. Sorry, I gotta read it again. 12.5 meters away. So you have an archer with a bow and an arrow, and there's a target over here. All right. At what vertical distance below the point of release will the archer hit the target and neglect air friction? Again, an archer doesn't aim at the bullseye. An archer actually has to aim a little bit above it because they know that gravity is going to be working on that arrow as it flies through the air. So I'm looking for the vertical distance. I'm looking for dy. So again, I know that time is my connector. I know that velocity horizontally stays the same. And I know that horizontal velocity is equal to horizontal distance or displacement divided by time. I know two of those three. I know this is 70.1, I know this is 12.5, and I want to know t. So I can actually figure out t because I can do 12.5 divided by 70.1, and what I end up with for time is 0.178 seconds. So that arrow's only in the air for like almost 0.2 of a second. That's it. It doesn't take long. So it's not in the air for very long. So I shouldn't get a huge displacement vertically because gravity does not have very much time to work here. So displacement vertically is equal to initial velocity times time plus 1/2 a t squared. So I just messed that up big time. A t squared. Don't know why I did that. So displacement vertically is what I want to know. Initial velocity is nothing. Plus 1/2 gravity is 9.81. And my time is 0.178 squared. So that's gone. So I should be able to do follow order of operations here. 0.178 squared times 9.81 times 1/2. Turns out that it is 0.156 meters. 3 significant figures because I had 3 significant figures in my question. Again, that's not a huge displacement. That's like 15 centimeters. That makes sense because again, the arrow's not in the air very long, so gravity does not have a long time to work on it. All right. So that's number 4. Number 5. I got a lot of questions on number 5. I saw number 5 go by several times in the messages. So I'm not sure what about 5 because I haven't read it yet. I'm not sure what about 5 is causing issues, but let's see if we can figure it out. The calculations I appear to have done don't look overly complex, look very similar. So let's see. In a physics experiment, you are rolling a golf ball off a table. So you have a table, you have a golf ball, you're going to roll it off the table. If the tabletop is 1.22 meters above the floor, so my horizontal displacement is 1.22 meters, and the golf ball hits the floor 1.52 meters horizontally from the table. So when you hit it, it goes here, and it is 1.52 meters away. The question is, what was the initial velocity? Now that has to be in the x direction because vertically there wasn't any, it was 0. So it has to be the x, okay? So again, in terms of horizontally, my velocity in the x direction, which is constant, is equal to my displacement over my time. Well, my displacement is 1.52. I need a time. I don't have one, but can I get one? I don't know. Let's find out. The formula that comes to mind is the y displacement is equal to the initial velocity times time plus 1/2 at squared. That's the one we keep using. So I actually have this time, 1.22. Again, in the y direction, vertically, my initial velocity is 0, plus 1/2 times 9.81 times t squared. I should be able to figure that out, because that would be 4.905. So 1.22 divided by 4.905, and then take the square root. I got that t should be 0.499 seconds. So the ball is falling for almost half a second. So 0.499 goes here, and vertically works out to be 3.05 meters per second. All right. Yay me. All right. Number 9 was the next one, and again, I saw this question a few times. And so that is on, it's in the next section. Not everybody, in fact, only a few of you at this time of day had handed in the homework for this. It's not due until midnight tonight, I realize that, but I thought I would answer them now. Again, if I don't answer a question that you have, watch the video, see if maybe you're missing something, and maybe you can figure out what it is you're doing wrong, because they are fairly similar in terms of what you need to do. So, in number 9, instead of starting with just a vertical velocity, they're actually starting with a velocity that is at an angle. So not only do you have to think about breaking it apart into its components for the final velocity, but you have to think about that for the initial velocity as well. So for number 9, you're hiking in the wilderness, you come to the top of a cliff that is 60 meters high. dy 60 meters. You throw a stone from the cliff, giving it an initial velocity of 21 meters per second at 35 degrees above the horizontal. And from there to there, I forgot. I swear I have Alzheimer's. 21 meters per second at an angle of 35 degrees with above the horizontal. So what are they talking about? They're talking about you have a cliff. You're standing on the cliff. You don't just throw the rock straight out. You actually throw it up a little bit, and then it comes down. That up a little bit is actually at an angle of 35 degrees with the horizontal. So I'm going to blow that up a little bit, that part right there. Here's my 35 degrees with the horizontal, and my velocity is 21 meters per second. That is the resultant. That is the hypotenuse. What I need is I need a velocity in the x direction, and I need a velocity in the y direction. Those would be initial velocities. Okay, those would be initial velocities. So the very first thing I do is some trig. And so for the y direction, that is the opposite side, so that would be sine. So the initial velocity in the y direction would be 21 times sine of 35, which works out to be 12.05. So that is the initial velocity in the y direction. Now remember, in the y direction, that's the vertical direction, there is a force acting on it, it's gravity, and so that velocity will change throughout the path of the rock. However, when I figure out the initial velocity in the x direction, that is the adjacent side, so that's cosine. So it's 21 cos of 35. And when I figured that out, it's 17.2 meters per second. Now again, this is not just initial, that is velocity in the horizontal direction overall, because it doesn't change, because there's no force horizontally, only vertically. So the question that they asked me, I haven't even gotten to the question yet, how far from the base of the cliff does the stone land? So I'm actually looking for dx. I want to know how far does it land. All right, so now this becomes very, very similar to a question in the last section. The only difference was I had to figure out those initial velocities. Now, the fact that your initial velocity in the y direction is no longer 0 is going to complicate your life. There's just no way around it. It is. So, what was the thing that we normally did? We normally figured out time first. And the way that we did that was by saying that dy is equal to initial velocity in the y direction times time plus 1/2 acceleration times time squared. This question is no different. There's just a problem with it. So in the y direction, that's 60 is equal to initial velocity in the y, and again, that's not 0 anymore. That's 12.05 t plus 1/2 9.81 times t squared. Now, again, we're going to end up doing the quadratic formula. So it is really important in this to consider direction so that you can put appropriate signs on. The rock is going downward. The displacement is down. So I'm going to put a negative on that. And gravity is working down. So I'm going to put a negative on that. In this case, it matters because when I move everything over to one side, this is going to be 4.905 t squared because this is negative 4.905, but when I move it over here, it becomes positive. When I move this over, it becomes minus 12.05 t, and this stays minus 60 because I'm not moving it anywhere, is equal to 0. This is now a quadratic equation. So my A is this is my A, my B is negative 12.05, and my C is negative 60. Very important that you pay attention to that. So when you do the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, you're going to get two answers. And again, the reason for the two answers is because it is the time is in two different places, okay? It could be, well, actually it's going to be here, or technically speaking, it would be back here, but that time's going to work out to be negative, which doesn't make any sense. So you take the positive one. And so t, for me, ended up being 4.94. If it doesn't for you, you've done something wrong with your calculation. I've done this question several times. It's 4.94. So now that I have my time, velocity in the x direction is equal to displacement in the x direction over time. Velocity is 17.2, I figured that out back here, is equal to displacement over 4.94. So I just multiply those two, and I get that my displacement is 84.9, which I can only have two significant figures because 21 was only 2. And so that is 85 meters. So the rock is going to land 85 meters from the base of the cliff. Whew, that's number 9. Not a talking. All right, number 11. Let's see what we can figure out for number 11. Again, that was one that I saw repeated several times. I'm hoping at this point you're going, oh, I see what I did wrong, but in case you didn't, number 11 says, during baseball practice, you go up into the bleachers to retrieve a ball. You throw the ball back into the playing field at an angle of 42 degrees above the horizontal. So same sort of scenario as before. You're in the bleachers, you throw the ball down to the field. So the angle that you make when you throw it up, if you're like me, I'm a girl, I can't throw overhand, I would throw it underhand so it would go up. Is 42 degrees. So 42 degrees to the horizontal, and the initial velocity was, I lost it already, 15 meters per second. So initial velocity is 15 meters per second at an angle of 42 degrees. So I'm going to need to figure out my x and my y if the hypotenuse is 15. Now, if the ball is 5.3 meters above the level of the playing field when you throw it, what will be the velocity of the ball when it hits the ground of the playing field? So, my displacement in the y direction is 5.3, and I want to know an overall final velocity. So again, things you're going to need for a final velocity are a speed and an angle. So again, I need an initial velocity in the x direction. The x is the adjacent side, so that would be 15 times cos of 42. And remember, for x, even though I'm labeling it initial, it stays the same throughout. And I got that it's 11.15. Again, these are not answers. These are just numbers I need for later calculations, so don't round them off, at least not too much. That is probably rounded off, but I wouldn't round it any more than that. And in fact, I might even do more. And then in my y direction, it would be 15 sine of 42. And that is going to work out to be 10.04. So I did the same sort of thought process. I need a time because it's the only thing that connects the two directions. The only way to get that is dy is equal to initial velocity in the y direction times time plus 1/2 at squared. And again, I thought about the fact that I'm throwing the ball downward. So my dy is negative 5.3. My initial velocity, initially I was throwing it up. So that is positive, so 10.04 times t plus 1/2, now gravity's working downward, so negative 9.81 times t squared. So when I move everything over to one side, I have 4.905 t squared minus 10.04 t minus 5.3 equals 0. And again, I use that to figure out my time using the quadratic formula, and I got that time was 2.48 seconds. So if I knew that, what I did with that, so again, at the bottom, it's landing at an angle. I already know the velocity in the x direction, it's 11.15. But what I don't know is the final velocity in the y direction, so I need to figure that out. So final velocity in the y direction is equal to initial velocity in the y direction plus acceleration times time. So again, very important here that I think about signs. My final velocity is equal to my initial velocity, which would be 10.04, right? Yep, 10.04 plus acceleration is negative 9.81 because it's in the downward times time 2.48. Very important that you have the negative there, and my guess is that a lot of you weren't paying enough attention to the positives and negatives in your calculations. That is probably, if you were like, I didn't get any of them, it's probably has to do with signs. So check that really carefully. So when I do this, I'm actually going to end up doing 10.04 minus this. So my final velocity in the y direction for me ended up being negative 14.3. All right, so this is negative 14.3. And again, it makes sense because it's falling, so negative. Now, so final velocity then is going to be negative 14.3 squared, which is going to be a positive anyway, plus 11.15 squared. And then I'm going to take this square root. And so my final velocity for me when I did it, I could have two significant figures. So I got 18 meters per second. And then tan theta of y over x. No need to worry about the fact that there's a negative there. I would just do 14.3 over 11.15. And so theta for me ended up being 52 degrees. So again, that would be that angle, 52 degrees. All right. So I hope that that answered some questions. If it did, and there were other ones that you got wrong, go back and look at those. Now, I haven't looked at how long I've been recording this, but it feels like about 4 years. So this really is probably the length of a period. So consider this one of those days where I spend the whole period going over homework. That's it. That's all you're doing today. All right. So have a good day. Bye.